Now, when adding methods to structs in Go, you're not limited to adding methods that output struct data. Instead, you can also add methods that change data in a struct. So for that here, we could add a new function, which we maybe call clear user name. And this function should be a method of that user struct here. Therefore, in order to attach it, we of course, just as before with output user details, add this receiver argument here, where we point at this user struct and give it a name that can then be used inside of this clear username function body. And here we could now access the first name and, for example, set this to an empty string, and do the same for the last name, where we also access the last name and set this to an empty string to clear the name of the user. So now this here is a function that changes the data in the struct. So therefore, of course, we can go down here into our main function, and then maybe below the place where we output the user details for the first time, we use our app user struct and call clear username. And then we can again output the user details, and we should of course now see the data we passed to this application when we output the user details for the first time. But once we then cleared the username, we would expect to get the same details but with an empty username, so an empty first and last name. Therefore, if we save this, we can run this application and fill in our details here as we did so often. And if we hit enter, we get something strange. We can see the data we entered here in the first output, but then we see the same data again in this second output, which comes from this line of code here, and that's of course not expected. So why is that happening? Because in this clear username function, in this method here, we are receiving a value of type user. And what's important to understand is that these receiver arguments work just like regular parameters. And there you learned that for these regular parameters, the values are passed around as copies. So when I call getUserData here, and I pass in this text, for example, this text, as you learned, is copied, and I get a copy of that text inside of getUserData. And the same thing happens here in my methods. Now, when we output the data, that's no problem, except for the extra memory that's occupied. That could be a problem if we have a very complex struct, which we don't have here, but that could be a problem. But it will be a problem if we have a method that should change a struct, because we get a copy here. So we're changing the copy. The original struct is not changed. So when I create a struct here in my main function, and I then call clear username, a copy is created and edited. And therefore, when I then call output user details again on my original struct, a new copy of that unchanged original struct is created, and I output the user details for that, and therefore there nothing changed, because the original app user struct never changed, because a copy was used here when I called clear username. And therefore, when you define methods that should edit a struct, you should not accept the struct as a value like this, but instead as a pointer by adding this asterisk. You can also do that for methods that only output data, like this one. For example, to make sure that no extra memory is occupied, because no copy will be created. But it's not mandatory here. But you do need to add it here. Otherwise, you're always editing a copy, and that, of course, is not helpful. So by making sure that a pointer is received here, the code will work. And you don't need to change anything else. You don't need to dereference the struct down there or anything like that. Instead, Go will make sure that a pointer is passed to clear username. And as you learned, we can use that shortcut on pointers so that we don't have to use this longer, more clunky dereferencing syntax. And hence, this code here will continue to work, but will now edit the original value since we now get the address of that original struct value instead of getting a copy. Therefore, with this change made, we can now run this application again, enter our details here again, and you now see that I get the full output here when the data is output for the first time, but then thereafter I get no name anymore. Instead, I just get the birth date because the name indeed now was cleared with help of this method here, which now does receive a pointer, which is required in order to let this method edit the original struct.